Hello all, good morning. This is Aravind from Bangalore. Let's get started and welcome to the second part of Programming Logic and Coding section of TCS Digital, TCS Ninja National Qualifier Test 2020. The last time what we have discussed is last time we've discussed close to some 7 to 8 problems. So few problems were MCQ based, and then 2 or 3 problems we discussed in coding section as well, right? So this time again we are going to be seeing some programming logic question, that is MCQ based question, and also coding section. Okay, so I request you guys to watch till the end of the video so that you will get the entire idea of what is TCS Ninja programming logic section and coding section is all about. Okay, so let's get started. So last time around we started off with C, and then we did few array problems and then matrix problems, so on and so forth. So this time around what we are going to do is today's entire discussion will be most probably from advanced programming like data structures. So basically it will be a little advanced coding section kind of thing that we will be discussing today. So if you have missed the first YouTube live, I request you to stick on to Aptimitra channel, subscribe, and then you will be able to get the entire idea of the last time pointer based and then C based question as well. So without wasting much of time, let's get started. So in today's concept, again, in order to go through the linked list and then few, uh, data structure based concept, I actually reinstate on few things which are very, very basic, and then from C programming language, which will be most frequently asked MCQ question, and also from data structure point of view. Okay, so let's get started. No, yeah, guys, you can try answering this question. This is again from TCS Ninja based kind of a question. You can just check it out and then try answering this question. Okay, what will be the output of question number 2? That is int I equal to 10, j equal to 20, pointer stores an address of I. So what will be the output of this question? So last time around we discussed few pointer based question. I hope you guys remember that, and then this is a kind of an little advanced version of the same pointer based question. So try answering this question, guys. Okay, so let's figure out what is happening here. So guys, you just have to remember one important point. Pointers are used for storing the address of another variable. Okay, that's what is pointer. So now let's assume that so we have I equal to 10. So that means I'm going to say the value of I, right, over here, I value. So in this line, if you see, the I value is here, I value is 10, and then j value is 20. Okay, so quickly, if you have to put that in a table kind of a thing, so here will be my variable name, and then the next will be my value of the variable, and then next will be my address. Okay, address of a particular variable. Now here in my case, I have a value I, right? The variable name is I, and then the value is 10. And let's understand, or let's assume that the address of I is 1000. Okay, it could be anything. I'm just assuming it is 1000. Okay. Now I have one more variable name, that is J, and then whose value is 20. And let's assume that the address of variable J is somewhere in 2000. Okay. All these addresses are just an assumption value. It can be anything, right? Now I have a variable P, but that's not a normal variable, that's a pointer variable. So pointer variables are used for storing the address of another variable. Okay. Now, the moment you see ampersand symbol, that means it is address of. The moment you see pointer symbol, in the last video we have discussed that it is content of. Okay. So now P will be storing the address of I, and let's assume that P's address is 3000. Okay. Address of I is 1000, so that's why I have marked it as 1000 here. Now PP will be storing the address of P itself. So address of P is 3000, and here let's assume that PP's address is 4000. Okay, so till here is everything fine. Now the next line says content of PP. Okay, so the moment you see content of PP, now how do we write this? So we write this as content of PP. Now the moment we say PP, then we are speaking about PP is nothing but 3000, right? You can see I is 10, J is 20, P is 1000. Likewise, PP is 3000. Okay. So PP is 3000 over here. So I'm just putting 3000 here, right? So content of 3000 is nothing but content of. So here content of 3000. So content of 3000 is 1000, right? So content of 3000, I mean the value which is stored in 3000, that is 1000. So I'm putting 1000 over here, and then content of 1000 will become 10, right? That is content of 1000 is here, right? So I'm going to change this space to 90. So wherever 10 is there, you change it to 90. Now once that is done, P is equal to null. So if P is equal to null, so this becomes null. Okay, so this becomes null. So the next statement says content of PP is equal to 100. Now if content of PP is 100, then I would like to say that it is content of 3000 is equal to 100, right? That's what they are trying to say. Now content of 3000, is actually null. So that means what? Content of null should become 100. So we cannot access content of null in anywhere, right? So this program gives an error. So I hope you guys understood this. So this program will give an error. So guys, all you have to understand is very simple thing. Now you cannot access the content of null. You will not be able to access the content of null at any given point of time. Okay, so that's what we need to understand over here. Yes, correct, Akash. Your answer is right. So it is error. Okay, it will not be 100, it will not be 90, it will be an error. The reason is you cannot access the content of null. So in the same way, try answering the next question, guys. We will quickly move on. Yes, Akash, what's the answer for star PP? Okay, so star PP will be content of PP. Content of PP is actually null. Okay, you will be getting null. So if you remove one star from here, okay, if you're going to remove one star from here, it is going to give you 0, because null's decimal representation of null will be 0. So that is going to give you answer 0. Yeah, guys, you can try answering this question now. So for this question as well, it is pretty clear here. Okay, very similar thing that we have seen in the last program. So here again, what we are supposed to do is just put one table, variable, value, and address. So quickly when we go through this, so we can see I is equal to 10, and let's assume I's value is 1000, I's address is 1000, J value is 20, and let's assume J's address is 2000. And now P is going to store the address of I, that means it will store 1000, and P's address can be anything. Let's assume it as 3000. Now PP will be storing the address of P. Address of P is 3000, and then over here I'm going to keep address of PP as 4000. It could be anything for that matter. So once this is done, now what we are saying is content of PP should become 90. So that means what? So content of PP should become 90. Now if that is the case, then we are speaking about content of PP is 3000. That should become 90. Now this can be modified as content of 1000. That should become 90. So when content of 1000 is becoming 90, we are speaking about this, and then we are changing 90 here, right? And after some point of time, P is actually having the address of J. That means I'm going to say here put 2000. Now once that is done, again we are accessing content of PP, right? Again we are trying to print content of PP. Now this time around it will become content of 3000. Now content of 3000 is content of 2000. So content of 2000 is 20. So the answer is going to be 20. The answer cannot be 90. So the same logic when we saw in the last program, that's the same logic of getting applied over here. Okay. So I hope this is clear, guys. So I'll tell you from where you can prepare these kind of programming logic pointer based question. So there is a portal which we have, in which you can start preparing for these kind of pointer based question. You can make a note of this website. It is also available in the description of this video. So this is having TCS Ninja based questions, programming logic question, as well as English section, as well as coding section. So this one has everything what is required for TCS Ninja. Okay, all the questions are uploaded here. So kindly check out this website, and then it will be a great help for you guys. Okay, so aptimitra.com, please make a note of this website. Okay, so let's move on to the next one. So the next one is little different from the previous ones, because here is where they are actually testing the data structures concept of students. Okay, how good are they in data structures? Now when it comes to data structures like linked list arrays, so these are the data structures usually will be asked in TCS Ninja. More advanced will be asked in TCS Digital. So let's focus getting the questions right from data structures in today's class. Okay, so the first question is, consider an implementation of an unsorted singly linked list. So for those who don't know what is a linked list, you don't have to worry. I'll be speaking about linked list here today. Okay, so consider an implementation of unsorted linked list. Suppose it has a representation with a head and a tail pointer. Given the representation, which of the following operation can be performed, can be implemented in O of one time? Okay, so for this question, you need to know what is linked list. They are actually testing you with the concept of linked list, and also they are actually testing you with the concept of algorithms. Okay, so here is where the few very tough concepts comes from. Okay, so there is a concept called as time complexity of an algorithm. So that is what is denoted as O of 1 over here. So these are the very important questions when it comes to algorithms. Okay, one of the main important topic is time complexity. So let's discuss about linked list first, and then let's figure out how do we solve this particular question. Okay, So linked list basically contains collection of nodes. Linked list is collection of nodes. The moment I say collection of nodes, how it is arranged is, it is arranged in the sequence. It is a kind of a chain. Okay. So probably the best example that you would have seen in the book will be train. Okay. So train is a collection of compartments, right? Likewise, linked list is a collection of node. So each and every node is going to contain two different things. It will be data and it will be a link to the next node. Okay, each and every node contains data and link to the next node. So this is what we call it as singly linked list. Okay, we call this as singly linked list. Now data could be of any data type. Data could be of int, char array. If you want anything, you can put whatever you want. Okay, that's not important over here. But data could be of any data type, right? That's the whole point here. But the link to the next node will be the address of the next node. And now we very well know that if it is address of a next node, if you have to store the address of a particular node, or if you have to store an address of a particular variable, all you need is a pointer. Right? So please get this right, guys. So in a node, we are going to have data and we are going to have link to the next node. Okay, that is a pointer. So I would say that node is a collection of int or char or whatever it is. So let's understand that it is int. Let's assume that it is an int for now. Data is int for now, and then a pointer. So an integer and a pointer to the next node. Okay. Now, if that is the case, what I have to do is, so what I have to do over here is, it is a simple logic now. I know that node is going to contain heterogeneous data, right? That means data of a different types. So if it is data of different types, then what I have to do is, I cannot implement it using array. Array is gone. I cannot be using array to implement this because it is containing data of different data types. So array can be used only if we can have same data type, right? Because the moment you declare array, right, you remember declaring an array, so it will be like this, correct? You can only have all 5 whole integers, right? But linked list is going to contain, node is going to contain data of different data types. Now if it is containing data of different data types, I cannot use arrays. I can use something called as structure in C, okay, or classes in Java. Okay, so don't worry, in this video we'll be speaking about C so that you guys can code in C, and then probably I'll make Java also available in some time. Okay, so over here it is simple. We need to use structure. So if you are going to use structure, the basic the basic syntax we need to know. So I'm going to create a structure like this. Okay, so struct contains struct keyword, and then the node, that is the name of the structure, and then my data will be an integer, and then after that I'm going to have link to the next node, that is a pointer to the next node. Okay, now if we have to have a pointer, we know that pointer needs a data type, because the moment you create a pointer, right, we do int star p, right, something like that, right? So likewise, the data type of this pointer will be node itself, because that is going to store address of a next node, right? So it is going to store address of a node, so that's why it is node star. Okay, so let's open my text code editor and then start coding from here. So I'm going to create a structure that's called as node, and then I'm going to have int data type for data, and then node pointer for next node, and a semicolon over here. So in C program, how it works is, every time here you are using node, you might have to specify struct over here. Okay, so I'm going to use struct here. Okay, now in Java, how do we create object? In Java or in C++, how do we create objects? We create objects, for example, class name equals, so class name C equals, or class name obj equals, or whatever it is. new class name of. Like this only we create objects. So in C, we don't have objects, but we need to have dynamic memory allocation. So if we need to have dynamic memory allocation, we use a function called as malloc. Okay, we use a function called as malloc. Malloc is used for allocating memory, so that's why it is called as malloc memory allocation. Okay, now what do we need to pass? We need to pass how many bytes I want. To malloc, we need to pass how many bytes I want. So I want 20 bytes, I want 30 bytes, I want 45 bytes, I want 50 bytes, things like that. Okay, so I need to calculate the size of the node over here, and those many bytes I need. Okay, so for example, we know that the size of integer is 4 bytes or 2 bytes, right? According to the compiler. Now, if it is according to the compiler, how do I calculate the size of a particular variable? We can use an operator called as size of, and then specify a data type over here, and then it is going to give you those many number of bytes. So malloc stands for memory allocation, guys. Okay, so it is used for allocating memory to variables. That's it, as simple as that. Dynamic allocation of memory happens through malloc in C. Dynamic memory allocation happens via keyword called as new in C++ or in Java. Okay, so this is dynamic memory allocation. Malloc is dynamic memory allocation, which is equal to new in C++ and Java. Okay, now here I'm going to say size of node. Okay, so how many bytes I need? I need these many number of bytes. I need node number of bytes. Okay, I don't need how many bytes a node is going to occupy. That's why I'm using a size of operator. Size of is an operator which is used to calculate size of a particular variable. That's it. Okay, now once that is done, I need to be storing this in a pointer. Okay, in a pointer. Now first node in a linked list is called as head node. Okay, the first node that we are going to create, remember guys, linked list is collection of nodes. Okay, so the first node in a linked list is called as head node. Okay, so that's why I'm going to have the name called as head here, and then usually malloc returns void pointer. Okay, so let's understand one thing here. So if a particular function is returning int and you are expecting a character, again I'll repeat, if a particular function is returning an integer and we are expecting a character, we can do something called as typecasting. So that is what I'm going to do. Malloc is returning void pointer, but I want a node pointer. You guys understand this? Because I want a node pointer, I don't need void pointer. So I need to do node pointer here. Okay, so this will typecast void pointer to node pointer, and I can store it here. Okay, so that means what? I have created one pointer, that is I have created one node. Okay, once I have created one node, I can access the elements of it using an arrow operator. Guys, please check it out. In C++ and Java, we use dot operator, and in C we use arrow operator for structures. Okay, arrow operator for structure. Now head.data, since it is an integer data type, we can give some integer value. Okay, so now by this I have created one single node, okay, whose data is 5, and that node, since it is the only node, it is not having any next node, right? As simple as that. So what they are trying to say is, in this question, let's go back to the question. So in this question, what they are saying is, let's assume that I have a singly linked list which is unsorted. So I'm going to erase this, and I have a singly linked list which is unsorted. Suppose it has representation with head and tail pointer. Head pointer is the one which is pointing to the first node. Tail pointer is the one which is pointing to the last node. Okay. So if I have things like that, let's say for example, this is the first node that I have. I have 5 and I have 8. I have 4 and I have 2 and I have 1. I have 9. Something like this. So these are the collection of nodes. And now if you observe here, so if you observe here, this is called as head pointer and this is called as tail pointer. Okay, now what they are trying to say is, insertion at the front of a linked list will take how much time, right? That's what we need to do here. That's what we need to calculate here. Now insertion at the front of a linked list is all we need is what? We need to create one node. Okay, I have created one node here, which is like 6 or whatever it is. Okay, I have created one node here, and let's name this node as new node or something. Okay, I have created it. Now once I have created it, now my next step is just to just to kind of create the connection between new node and head. Okay, so for that all I need is see, simple guys, new node should be, so new node should become the first node. That's it, as simple as that. So for that what I need is new node of next will be pointing to the same address as head is pointing to. New node dot next equals head, and then after that head should change, right guys? Are you able to understand this? So head should point to the same node as new node, right? As simple as that. Now this is what it is required for the first one. So this is what is required for the first one. If you are not able to understand this, hold on for a moment. We will explain it again in a very in-depth way. Okay. So what I'm trying to say is we don't need a loop for this. Okay. Insertion at the front of a linked list doesn't require a loop. At the same time, insertion at the end of the linked list also doesn't need a loop. Okay. At the same time, deletion at the front of a linked list also doesn't need a loop. So for example, if you have to insert a node at an end of a linked list, end of a linked list will be like, let's say 7, and then that will become a new node now. Now all I have to do for this one is you just have to do new node. So tail dot next should become the new node. So that means I'll be able to put this right away in this block, right? Within this table, I'll be able to bring this 7, right? And then tail should get changed to new node itself, because tail has to be the last node, right? So even for this, I don't need a loop. The third one says deletion at the front of a linked list. Deletion at the front of a linked list means I just need to change the head. That's it, as simple as that, right? So deletion at the front of a linked list will become will be very simple. Head is equal to head dot next. That's it, as simple as that, right? But the problem here in fourth one is deletion of a last node of a linked list. So deletion at the last node of a linked list requires tail to be moved to the previous one. But since it is a singly linked list, all we have is the data and the link to the next node. So if it is linked to the next node, then we don't have link to the previous node. That means what? The last option cannot be performed in O of 1 time. Last option requires O of n. Okay, which means I need a loop to find out which is the node which is previous to the tail. Because you guys remember what we have to do for deleting the last node? For deleting the last node, what we have to do is identify the previous one. Identify the previous node. So let's name this node as temp. Okay. Now temp.next is actually null. Okay. Temp.next is actually pointing to the same object as null, but we don't want that. What we want is temp.next is equal to null. So that means so temp.next will now not point to null, not point to tail, but it will point to null. That means that becomes the end of the linked list. That becomes the end of the linked list. Now once that becomes the end of the linked list, we need to be changing the tail. So tail is equal to temp. So in order to identify the previous node, we need a for loop. So when we take a for loop will run from 0 to n minus 1, right? Or n minus 2 in our case right now, because we need to identify the node which is previous to the tail. So that means we need to run a loop from from 0 to n minus 2. That means the complexity of this will be O of n and not O of 1. So that means deletion of a last node of a linked list requires O of n time. That means the last option is not the correct one. The first three options are the correct one. Okay, this is wrong. The fourth option is wrong. So if you are not able to understand, hold on, we will be discussing two coding questions based on linked list. So at that time, you will be able to understand this in a very clear way. Okay, so what if it is a doubly linked list? So if it is a doubly linked list, yes, I understand all four will be O of 1. Okay, if it is a doubly linked list, all four will be O of 1. That's right, Akash. If it is a doubly linked list, then it will be all. Okay, since tail will also hold the pointer to the previous one, we don't have to write a loop for identifying the previous node. That's it. So that means all four will be O of 1 only and only if it is a doubly linked list. But the question clearly says it is a singly linked list. Okay, so that means what? It is only first three which are right. The last option is not right. Okay, so for those who are not able to understand this, we'll go back to the code and then you will I'll make you to understand this as well. Okay, now if it is a linked list, guys, very simple. Linked list is a collection of nodes, as we know. So we can create one more node just like this. So I'm going to name this as second node. Okay, second node's data I'm going to keep it as 10. Okay, now guys, what I have done is simple one. I have just created two different nodes. Okay, node number one is having data. So you guys understand, right? So the first one is so the node name is head, data is 5, and then next is null. So this is the pointer to the node, and this is the value, and this is next. Actually, this we have named this as data, right? So this is what happens for the first one. Okay, now for the next one, I have created a pointer called as second, whose data is 10, and next is null. Now let's do one more important thing, like how we did it for the pointer concept. I'm going to store the address of the node. Okay, address of this node. Now let's assume that address of this particular node is 1000. Okay, it could be anything. And then address of the second node could be anything. So let's understand it as 2000. Okay, so now guys, so the head node next value is currently null, correct? But in order to create a chain of linked list, what I have to do is I have to store the address of second node in head of next, right? Address of the second node should be stored in head of next. That means I need to store 2000 here. Now, how do we get the address of the second node? Address of the second node, since it is pointer, it will be holding the address itself. So what I can do here is address of the second node is obtained by just using a variable called as second itself. And here I need to just do head.next is equal to second. So likewise, I'm going to create one more node. Let's call it as third. And let us have the data of third node as 15. Now, once I have third node as 15, here I have created a node third node, and then this becomes 15, and then the next of it will obviously be null, and then it will be 3000. Now what I have to do is I want the data of I want the address of the third node to be here. That means it has to store 3000 here. Now how do I do that? Simple. So you can just do by doing second.next is equal to third. Okay, now once this is done, I have three different nodes. Now let's write one function for displaying the elements of a linked list using head pointer. Okay. Now I'm going to just say display, and then I'm going to take one pointer to the node that is head. Okay. So don't worry guys, I'll be uploading one book which speaks about the basics of data structure. The book contains only 60 pages, 60 to 70 pages, and it will cover all the most basic data structures that are used in the industry that will be most probably asked in TCS Ninja. So all those things are, for example, arrays, linked list, all the algorithms related to arrays, binary search, everything, and then all the algorithms linked with linear search, sequential search, everything, linear linked list. And then also it speaks about trees, where we are speaking about in-order traversal, pre-order traversal. So the book contains each and everything. The book link is also available in the description, but if you want, you can make a note of that here itself. So this is the link. You can check it out. You can download the zip folder which contains C basics, C advanced, data structure basic, data structures advanced, algorithm basics, and then algorithm advanced. So each and every book contains only 60 pages. It will be very crisp. You can it contains program, and also it contains diagrammatical expression representation. Okay, it will be easy for you guys to understand. Now the whole point is here, if I have the head node, right guys, now see here, I can print the data by using the head node, and I can go to the next node just by saying head is equal to head.next. That means I am moving. So like how we used to write a for loop, you guys remember, right? So we do I++, correct? That's for increment. So likewise, I'm going to write one loop just for displaying all the elements of a linked list. For that, I'm going to create one variable called as temp. In for loop case, it will be I. In while loop case, I'm going to just assume it as temp. And I'm just saying while temp not equal to null, while temp not equal to null, I'm just going to print the data of that particular node. So if I have to print the data of that particular node, you guys know what we have to do. We need to access data, right? And as an increment part, so this is my initialization part, just like for loop. Okay, and this is like a printing part, printing, right? And for me, the increment will be temp is equal to temp.next. That means now temp will be pointing to the next object in the next loop, right? In the next iteration of the loop, temp will be pointing to the next object and not the current object. Now this speaks about the increment. Okay, so now once I have this, I'm going to call this by just using the head node. Okay, now a little syntax changes, guys. I'm going to use a thing called as type def here. So in C language, how structure works is, structure is used for creating user-defined data types. Okay, so in order to create a user-defined data type, I'm using a keyword called as type def, and you can use the same name of the structure name here so that it creates a data type of that particular name. Okay, in that particular name, it will create a one more data type, right? So that's why I'm using this struct. And also for using malloc, please include stdlib.h. Okay. So if you guys remember, the first one is speaking about the in the first session, I spoke about the repellent. So I'm using the same to execute this code as well. So the moment I execute this, you can see, guys, it will be 5, 10, and 15. We are able to display 5, 10, and 15. Now, guys, the question that they have asked in TCS Digital in one of the question paper is a very basic, simple question again. So what they have asked us to do is we need to detect if it is a circular linked list or not. Okay, if a linked list is circular or not, that's the question that they have asked. Now, if it is a circular linked list, guys, so let's go back to the basics. Let's copy this. Okay, So if it is a circular linked list, simple guys, what would have happened is circular linked list are some linked list. It's a linked list basically, which in which last node points to the first node again. Okay, the last node of the linked list will be pointing to the first node again. So if the last node of a linked list pointing to the first node, then what we are speaking about is this will contain 1000 again. Right, as simple as that, correct? So the last nodes next will be pointing to the first node again. So that is what is called as circular linked list. Okay, so even in the book circular linked list is available, guys. You can download and then get a deep insight about circular linked list. So what they have asked us to find is, given the head, how do we find whether it is a circular linked list or not? So I'm going to create a circular linked list here, in which third dot next is pointing to the head again. Okay, third dot next is pointing to the head again. Now if this is the case, I'm going to copy this and execute it. You can see what is going to happen to our code. I'll try running this. You can see it keeps printing 5 10 15 5 10 15 5 10 15 and so on. Okay, now this is happening. I'll stop this. So this is happening because temp will never be null. Since it is a circular linked list, it keeps moving. Okay, circular, I mean the basis of linked list is simple, guys. It understands only the first node. Okay, it understands only the first node, and circular linked list will not have the last node at all. Right, that's why it is called as circle. Right, simple, guys. If you are running on a circular track, okay, if you are running on a circular track, let's assume that you are running on a running race. You are participating on a running race. Now if you just start running from the running race at the first starting point, you just keep moving because it is a circular track, right? And then you again come back to the same, again you come back to the same, again you come back to the same position, right? So that means what? We are actually got stuck in a circular track, right? So there is no end. There is no end for the road itself. There is no end for the track itself. Now that is what is circular linked list. Now how do we detect if it is a circular linked list or not? Simple, guys. If the last node points to the first node again, then it means it is a circular linked list, right? As simple, right? If the last node points to the first node again, then it is a circular linked list. Then it means what? But the problem here is we don't know what is the last node, because in a circular linked list, all we have is the first node, that is the head node. We don't know which one is the last node. So that's the whole problem. So what we do for this is simple, guys. So if you observe this, here temp is never becoming null. Okay, temp is not again becoming null, but there is a point where temp is actually pointing to head again. Okay, temp is again pointing to head in one particular point of time. Now if temp is pointing to head again, we can easily predict if it is equal to head in any point of time, then we can surely say that it is circular, right? Simple, guys. I will start the temp from head of next. Okay, I will not start the temp from head, but instead I'll start the temp from head of next. That means I am starting the temp from second node. Okay, so here is where my temp is. Initially this is my temp. Initially I'm assuming the second node is the temp, and temp is not null. Go to the third one, make this as temp. This is not null. Again go to this. This is also not null, but this is equal to head, right? Here my temp will be equal to head. Then in that case, you can say that it is circular. The whole idea is just in entire loop, if my temp becomes equal to head, then that is where the cycle exists. Okay. So what I'm going to do is I'm just going to evaluate if temp equal to head, then you just have to print cycle and you can just break. Break will put you out of the loop. Okay, break will put you out of the entire while loop. Now Let's check running the code. So you can see 10 and 15 got printed. Why we are not able to print 5? We are not able to print 5 because temp starts from head of next. So we will never be able to point 5, right? Now that is why we are not getting the output 5. But after that, we are getting the output 10 and we are also getting the output 15. But again, the temp became head. And then here temp is equal to head becomes true. And then it prints cycle and then it breaks. Okay. So this is how you can check whether the linked list is having cycle or not. Okay, guys, any doubts in this? So I'll be putting this question as a zip file after the end of the show. So probably around 1:30 or 1:45, you guys can again check it out, the description. So the description will have the zip file. Okay. So, and very important thing, guys. So there is a question asked like this. Okay, where they are speaking about in order and then pre-order traversal of a binary tree. Okay, in order and pre-order traversal of a binary tree. Now this is again one of the most asked question in TCS Ninja. So this was also appearing in TCS Ninja mock examination that we have already got, right? Okay, Rachna, we get linked list questioning in coding section. See, Rachna, so there are two parts in coding section. So see, one part is a very basic coding, which you will get using arrays and strings. So that we discussed already in the previous class. We discussed one problem based on matrix, and then the other problem we discussed based on strings as well. You can check it out. It is available. That is one. The other one is we might get linked list. We are not sure about it because the syllabus includes data structure as well. Okay, they have included the syllabus data structure as well. So we might get in TCS NQT. So the type of coding questions that you might have to practice is basically predominantly they will be asking array and then string based question. There is no doubt about it. So arrays and string based question, definitely they are going to target. And then for data structures, you can stop probably in stack. Okay, stack or queue. You need not practice implementing trees and then graphs. Okay, those will happen in a very, very rare scenario in TCS Ninja NQT. So we don't have to practice graphs and trees as it is very, very complex. They might not ask questions from graphs and trees only in the coding section, but they have all the possibilities. We have all the possibilities that tree and then graphs questions are appearing in MCQs. Okay. So I would request you guys to at least have a basic idea about trees and graphs. So once you complete this video, you will have a fair idea about trees. There is no doubt about it because we are going to discuss a question on trees that will definitely help you guys. Okay, this is just for trees. Okay, very, very basic question they are going to ask. They will not be asking a very tough question in MCQ. They will be asking very basic questions in trees. Okay, like the one that I have showed you now, they will be asking very basic question. It will not be tough. So for coding questions, you can stick on to arrays and then strings. Max to max, you can try implementing linked list and maybe stack and queue. That is more than enough. Please do not focus on graphs and trees as it is very complex. It is very unlikely to come in the NQT, at least for Ninja. Okay. So yeah, having said that, guys, I would request you guys to stay till the end of the video because in the end of the video, we will be sharing a zip file. I'll be sharing the link for the file so you can download. Yeah, yes, you're right. Okay, Akash, you just have to practice string, array, linked list, stack, and queue. Now, when you're practicing string or array based question, it'll be good if you get practiced with one single programming language. It could be either C or Java or Python or anything. But when you are going for Python, make sure, guys, you are getting familiar with Python 2.7 because in the last mock test what we had, they had given only Python 2.7. They have not given Python 3. Okay, so if you are aware of Python, then you know the basic difference between Python 2.7 and then 3, right? There is a huge difference between those two versions. So make sure that you are getting accustomed with Python 2.7 if you're going to use Python. And then otherwise for Java, they give Java as well, so you don't have to worry about it. Java and C, both you can use, there is no problem. C++ also you can use. So if you're comfortable using C++, you can use C++ as well. And then they also give language Perl. You can use Perl as well. Yes, Subham, this video will be available after the live stream. There is no doubt about it. The video will be available in YouTube. You can access the video using the same link. You can copy the link over here. You will be able to access the video with the same link. Okay, so let's get straight to this one. In order, pre-order traversal of a binary tree, then you need to select the corresponding post-order traversal. So give it a try, guys. Try answering this question, and then let's discuss about this question in 2 minutes. Give it a try. Answer this question. Okay. Okay, guys. So let's start with this in order and pre-order traversal of a binary tree. Okay. So and then see, guys, simple thing here is in order traversal is basically L N R, and pre-order traversal is NLR. Okay, and then post-order traversal is LRN. Okay, so I'll tell you how do we remember this. Simple it is. N means node. N means node. L means left. R means right. Okay, so this is what it means. So now in this case, what we have to do is node means we just have to print the node, and left and then right. Okay, so let me open my paint just to kind of show you guys the visual structure. Guys, I'm trying drawing. Okay, so if it is very bad, don't scold me. So in order is LNR, and then pre-order is NLR, and then post order is LRN. Okay, so guys, it is simple that we can understand that. See, if node comes first, then in pre-order traversal, first will be the root node. Okay, the first one will be the root node in pre-order traversal. Okay, so the post order answer will contain the root node at the end of the expression. Okay, at the end of the expression only you will have a root node. So that means my post order, the answer for the post order will definitely have 1 at the last. Okay, 1 will be in the last in the post order, because in the pre-order first is the root node and in the post order last is the root node. So that means what? 1 is very, very clear. Okay, now in the in order, if you see, root node will come in the between. Okay, will be coming in the middle. Okay, that means what? All these three nodes are appearing to the left of 1 and these two nodes are appearing to the right of 1. Okay, are you guys understanding this? This is, so this is in order. I'm just copying the in order point. Okay, and we are saying that this is n. Okay, then that means what? All the nodes which are appearing to the left of 1 occurs left subtree of 1, and all the right elements appearing to the right of the 1 appears in the right subtree of 1. Okay, so now again it is clear. So all these nodes will be coming on the left hand side, all these nodes will be coming on the right hand side. Now if that is the case, next node is 2. Okay, once the next node is 2, you can construct one tree, so in which your first one, so your first node is 1 and your second node will be 2. Okay, now for the second time, what we are going to observe is, what we are going to understand is, this becomes my node. Okay, once this becomes my node, all the left hand side nodes which are appearing left of 2 will become left of 2, right? Left subtree of 2. So if that is the case, then 4 appears here and 5 appears here. Okay, now in 3 or 6, 3 appears first. Okay, since 3 appears first, we are going to put 3 here. Now the problem here is 6 can come here or 6 can come here, right? So for that reason, what we are going to do is, 3 is over here, so 6 is appearing to the right of 3. So that means 6 can come only here and not here. Now once the tree is constructed, we all know how do we do a post order traversal. Post order traversal is done by using LRN. So you do LRN and then you're going to get what you have to print first. Okay, so the first to get printed will be, let's say for example, I'm going to write LRN everywhere. Okay, so first I'm visiting the left side. First I'm visiting the left side. First I'm, there is no left side and there is no right side. So I'm going to print 4. Right, since all 3 are declared wrong, I mean declared completed, I'm going to go to the parent and I'm going to print the right is 5, and then I'm going to print the node is 2. And once this is done, I'm going to visit the right hand side of 1. For the right hand side of 1, 3 is not having any left, 3 is not 3 is having right, so right will be 6, and then 3 will get printed, and then finally 1 will get printed. Okay, 4, 5, 2, 6, 3, and then 1 will be my post order answer. So there is one point that you need to note down, guys. In one of the questions, what they have asked is, given the in order traversal, can you predict the post order? So they have given one in order, and then they are asking us to predict the post order traversal of a tree. In this case, it is not possible to do that. So what all it is possible is, we can just try predicting, but we will not be 100% sure. Okay, you need 2 in order to do the third one. Okay, that's the whole idea of it, because only then you will be able to construct a tree. For example, let's say 2, 1, 3 is my, let's assume anything. Okay, this is my in order, right? This is my in order. Now for this, let's try constructing the tree. So in order is simple. In order says what? Right, in order is for LNR. So if it is LNR, we can consider 2, and then 1, and then 3, because see, 2 appears and then 2's right 1 appears and 1's right 3 is appearing. We can do this, or we can also construct a tree like this, or we can also construct a tree like this. Okay, so many different structures are possible if it is only one given. Okay, so for that reason we will not be able to predict the other one if only one is given. So with in order, we need to either have pre-order or post-order in order to predict the other one. Otherwise, it is not 100% sure. We can try predicting based on the given options. Okay, if they are giving some ridiculous options, we will be able to eliminate them and then we will be able to select only one. So in this case, that is possible, but it is not 100% possible. Without option, we cannot definitely predict anything. Okay, but with given options, yeah, we will be able to do something. Okay, so for example, let's assume that they have just given pre-order. Okay, they have just given pre-order, they have not even given in order. Okay, and in the post order option we have something here, something like this, and then there is one more post order option that is something like this. Okay, they have given these two options. Now we can definitely predict this will be the answer, because in the pre-order traversal node occurs first, and then in post-order traversal whatever is occurring first, that will occur last, right? So that we know. So in this case, if these two are the options, we will be able to predict, but not otherwise. Okay, if we don't have option, we cannot write the entire statement. So check it out. If they have asked, if they have given the options which you can directly eliminate, then you can go and select, or otherwise please do not. There will be one more option called as insufficient data given, so you can go and then select that option. Okay, so there will be an option called as insufficient data. If you are not able to answer, if we are sure that we will not be able to get the answer, then you can select insufficient data as the correct option. Okay guys, okay, so this is done. Let's go back to our linked list concept where we were discussing about circular linked list. Now, in this circular linked list, there is one more concept called as looping linked list. Okay, a linked list which loops itself. Okay, so I'll just show you the diagram of what I'm actually saying. So for example, let's say I have a linked list. Okay, I have a linked list over here, and the data is 5. Now, this particular linked list is connected to another one, right? Another node, right? So this linked list is connected to another node, and let's assume that this particular node is having some random data, and this keeps repeating. So here you have multiple nodes. So let's assume that this node is 7 or whatever it is. Okay, and there is one more node which is of 8. Okay, now given the fact, we know that the linked list is going to be a sequential linked list, and here is where I have a head, right? Here is where I have an head pointer, and now the point over here is, we know that this will have null. The last node will be pointing to null. Now circular linked list is some linked list in which the last node will be pointing to the first node. This is what we saw in the previous one, right? So circular linked list is the one which contains the last node will be pointing to the first node itself. That is circular linked list. But in our case, the looping linked list will not have so. The looping linked list, the concept of looping linked list is, a node will be pointing to some other node. May not be the first node or might be the first node, but the problem here is this node's next is 6, this node's next is 7, this node's next is 8, and 8's next is 6, 6 next is 7, 7 next is 8. Again it is like looping. So we call this as looping linked list. Now in this case, it is very, very tough for us to again navigate, again go through the linked list and understand the structure. Okay, now how do we detect a loop in a linked list is what they have asked. Okay, so they have asked this in several times, not just in TCS Ninja, but also in different interview rounds. Okay, so they will be having a tech round. So even in the tech rounds, they have asked the students the same question again and again. So the idea is simple, guys. What I'm going to do is a very simple one. So I'm going to evaluate this. Let's assume that I have one circular track and there are two people. Okay, let's say there is a guy called as S and there is a guy called as F. Okay, there are two people. Now S is going to run 1 kilometer per hour. All these are assumptions. Okay, don't fight with me. So all these are just assumptions. And F is going to run for, let's say, 2 kilometers per hour. Okay, and now these guys, let's say these guys are starting from the same point. Okay, now we have two different tracks. One is the circular track and then the other one is a straight track. Let's say they are starting from this point. So this is the starting point in a straight track and this is the starting point in a circular track. Now the point here is, guys, if a guy starts from this point and he is running 1 kilometer per hour and then the fast guy is running 2 kilometers per hour, now there is a point, there will be a time where they both meet again, right? Where they both will be meeting again. But in a straight track, if they start from 1 kilometer per hour and then the other guy starts from 2 kilometer per hour, and let's assume that this is the finished track. Let's assume that this is a finished track because the straight linked list will have an end, right? That is the last node will be the end, right? So this will be the end. So that means what? S guy and F guy, both of them, when they start running, F will complete the race faster. Of course, there is no doubt about it. But without, they will not even, F guy will not even meet S guy. You got it? So I'm going to rename this F and S as slow and fast so that you guys understand clearly. So this guy will be a slow guy, the first guy, and then the second guy will be a fast guy. So fast guy will not be able to meet a slow guy at any given point of time in a straight track. If the track is straight, he will not be able to meet. But if the track is circular, he will be able to meet, right? So that's the whole point. I'm going to make these guys point to the first node, the slow guy and the fast guy. And now when the fast guy reaches the finish line faster first, then it means it is not circular. But if he is able to meet the slow guy again, then it means it is wrong. Then it means it is loop. For example, what I'm going to do is I'm going to make this slow guy move one step ahead. S will be S dot next. Okay, but I'm going to make this fast guy move 2 steps ahead. Just to show that he is fast, I'm making him to move 2 steps ahead. Okay, so if this is going to happen, what will happen initially is, so for the first time, S guy will be here. From here, there is one jump, he will be here. But for F, it will be here. Okay, for the next time, S will be here. And F will become 1 time and then 2 time jump will be here for F. And for the next time, S will again be here. And F will be 1 time and then 2 times, 2 jumps, and then F will be here. Now in this case, F and S, both of them are meeting the same node. That means it is loop. Okay, as simple as that. It has a loop. So now that is what we are going to do here. So we are going to create 2 different pointers. I'm going to remove this and I'm going to write one function called as detect circular or something. Okay, so maybe is loop. Okay, something like that we will write is loop, and then all I need is the head node. Guys, in the diagram, what we have done is we have started S and F with the first node, right? That is the second node, right? First node is the head, second node. We are starting it from the second node. So what I'm going to do is I'm going to create 2 different pointers. One will be slow and other one will be fast. they both will be starting from the second node. Okay, so once they both are starting from the second node, what I have to do is I need to, for every loop, I'm going to just write this. For each loop, slow will be slow of next, and then fast will be fast of next, because fast moves 2 times, right? And slow moves only 1 time. Now here I need to check if the slow and fast are equal, then I can print loop directed and I can break, right? As simple as that. So in order to make this a loop, so let's assume that this link is not there. So let's say this link is not there. This is destroyed. Let's also assume that this F and S is not here anymore. They start from the first. Okay. Now, guys, simple it is. Yes will, for the first time, yes will be here. For the first time, F will be here. Now, if it is not a loop, then what will happen is at any given point of time, fast dot next will be null. Okay. At some point of time, fast dot next will become null if it is not having the loop itself. Okay, if it is not having a loop, then fast dot next will become null at any given point of time. So that is what I'm going to write it in the loop. I'm going to say while fast dot next not equal to null, do the looping again and again. Okay, now here I can run this, but all we have to do is just call this function instead of display function. Okay, so let's run this code and then check once. Now I'm going to remove this point and I'm going to create fourth node just like the one that we have. So I'm going to create the fourth one. Let's say fourth node is data 20. And then here what we need to do is third next will be fourth. Third next will be pointing to fourth. Now let's try running this. Here we didn't get any output. That means it is not having any loop. Okay, right? It's not having any loop because four different nodes are separated. It's not having any loop. Now what I'm going to do is fourth dot next. I'm going to make it to point towards second. Okay, fourth dot next will be pointing to second. Fourth dot next, let it point to second. Now this is where it creates a loop, right, guys? So this is going to create a loop. So let's run this and you can see that it is loop detected. Okay, so this question is going to detect loop in this particular program is going to detect a loop in linked list. So we have successfully completed a program to create for identifying a loop in linked list. Okay, any questions, guys? Any questions in this one? So all we have done is just created a slow pointer and then a fast pointer. There are other ways to do it. There are other ways to in order to identify a loop in a linked list. But this is what is very, very easy for us to understand. And this is very practical also. Because if you have to identify a circular track, all you have to do is just ask one guy to run slower and then they ask the other guy to run faster. And then check if they both are meeting again. If they both are meeting again, then they are just circling at the same time, right? They are just circling. They are not going anywhere else, right? So that's the whole point here. So from that only we got this idea of having a slow pointer and a fast pointer. So this is a widely used concept. We call it as slow pointer and fast pointer concept. Okay. The concept used here is called as fast pointer and then slow pointer. Okay guys, so I have got one query here. So instead of not printing anything, if the loop is not there, let's say if the loop is not there here, we are not printing anything, right? We are not printing anything. So instead of that, can we print loop is not there? Okay, something like that. So that's the whole question here. That's the query that I've got. So what we can do is we can handle this in a two ways. So I'm going to show you how to handle this in one way. So let's say int loop directed or something. Initially it will be 0, and I'm here when the loop is directed, I'm going to make it as 1. Okay, outside the while loop, you can compare. If it is equal to 0, then you can print no loop directed. So this is one way you can check if the loop is there or not. So in both the cases, you will get definitely one output. If the loop is directed, you are making this as 1 so that this will not even get executed. If the loop is not getting directed, then still the loop directed will be 0. So this will be true, and then you will get no loop directed as the output. Okay. And also guys, there was one more question asked. That question is consecutive characters. Okay, so I will just explain this question to you and then we will start coding. So that question is fairly simple one, but it plays a lot with strings. So I thought we will discuss in this one so that you can check it out. How do we act? How do we do that? Okay. So the question is, we just have to print how many number of consecutive characters are there in a string. Okay. How many number of consecutive characters are there in a string, which is the maximum occurring. Okay. For example, let's say ABCD, ABCD, and then ABCDE, and then ABC. Okay, this is a given string, let's say. Okay, so if you observe this, so A and B, they both are consecutive occurring characters, and then B and C again is a consecutive occurring character. C and D is again consecutive occurring character, but D and A, they are not consecutively occurring character, right? So they are two different. So the overall objective of this question is, are you knowing ASCII values of each and every, are you knowing how to play with ASCII values? That's the whole point of checking this kind of things. Okay. So what we are going to do here is, we are going to take each and every character here. So this is a question which is asked in TCS Ninja. So what we are going to do, so they call it as consecutive characters question. Okay. So we need to give so D and A are not consecutively occurring characters. So till now what we have is 4 consecutive occurring characters, right? 4 consecutive characters. Correct. It is a group. Okay. 4 consecutive occurring characters for first. Okay. Initially. Now for this one, consecutive occurring characters are 5 for the second group, right? So there are 5 consecutive occurring characters. Now, if you take the third group, it is only 3 consecutive characters which are occurring. Okay. Now, not just that, if you don't have A, still B and C is a valid group because they both are consecutive characters, and that is 2. Right? It necessarily doesn't mean that we have to start from A. You can also start from B. Okay. So this is the question that they have asked. So let's try to solve this using C. You can also solve this using Java if you need. Okay. So I'm going to remove all the nodes and things like that. I'm going to make string.h. Okay. So all I'm going to do is I'm going to take a character array, or it's like a string in C, right? So I'm going to take a character array and I'm going to say this as str equals abc abcd e. Okay, a very simple one. In order to get the length of a string, I'm going to use a function called as strlen, which is available in string.h in C. Okay, so I'm going to write a loop and then check if I'm able to print all the characters. Printf %c str of I. Okay, guys, this is not the program that they have asked. I'm just checking out whether I'm able to print all the characters or not. Hola, yeah, I'm able to print all the characters, so this is done. Okay, the first step is done. So the next, I'm able to access character by character. So what I'm going to do now is I'm going to take the first character and then compare it with next. Okay, so a very quick thing that I'm going to do here, guys. Quick example here I want to show you. So for example, if I subtract b from a and then print it as an integer, okay, I'm just printing b minus a as an integer. Okay, if you observe this, interestingly, it gives 1. Okay, so you can see, interestingly, the output is 1. Now, why it is 1? That is because b's ASCII value, you can try printing b's ASCII value just like this. You will get it as 98. And a's ASCII value is 97. So 98 minus 97 is 1. So that's what I'm going to do here. I'm going to take the first character and then the second character. Second character is printed using I plus 1, right? As simple as that. Second character. And I'm going to print it as a decimal value and then check what will be the output here, right? So I'm going to take this code and then put it on my editor and then check it out what will be the output. Okay, so I'm going to do a new line so that we are understanding every line clearly. So for the first time, if you see, it's -1. Second time it's again -1. Second time is when I'm comparing B and C. Third time I'm comparing C and A. That is the reason why you can see it is 2. Okay, because C minus A is 2, right? And then the third time I'm doing A and B. Sorry, third time I'm doing A and B. Again, you can see it is -1. So the whole point is clear now. If I can count, if I can keep on integer and then keep an counter of it, if I can count, keep adding the counter, then if it is -1, okay, if the difference between the first character and the next character, if it is -1, and if I keep adding the counter, I will be able to get the counter value, right? As simple as that. So I'm going to take this out and I'm going to put it in if statement. So I don't want to compare it with -1 since negative integers are so difficult. So I'm just going to do my equal to 1 comparison and I'm going to increment a counter. Okay, so for this counter I need to have a counter here, a variable which starts from 0 or -1 or whatever it is. Okay, and for every time I'm going to just print the counter. Okay, for every loop I'm just going to keep printing the counter just to kind of make sure that it is working properly. So now let's run this and then check if counter is getting incremented or not. Okay, yeah, so we are able to get the counter, but so what we are expecting as the output, what TCS has asked in the question is we just need to print 5. Okay, you just have to print 5. Okay, output. Why output is 5? Because that is the maximum number of consecutive characters. Okay, that is the substring which is occurring which is having maximum number of consecutive characters. So you need to print the length of a substring which is having maximum number of consecutive characters. So that was the question. Now if that is the question, for the same code, let's copy the same string, and let's see what is the output that we are getting here. So we are getting counter as 8. So that is happening because we are not resetting the counter if it is not equal to 1, right? As simple as that, right? So we need to reset the counter, guys. Simple it is. When it is ABCD, we have the counter value as 4. Now when we have ABCDE, we need to reset the counter, right? So we need to reset the counter when D and A are meeting. When D and A are meeting, we need to reset the counter to 0 or 1 or whatever, that we will see, but we are sure that we need to reset. So if we need to reset, I'm going to say else counter equals to 1. Okay, I'm going to say the counter as 1 because let's assume that this is our substring. Now consecutive character is 1. We cannot say that there is no consecutive character. Consecutive character is 1, because if we say AB is a string, then the number of consecutive characters which are occurring is 2, right? There are 2 consecutive characters which are occurring. We will not say there is only 1. So that means what? I need to start the counter from 1. So that is why I have changed the counter to 1 here, and then I have changed the counter here to 1. Okay, let's copy this and try executing. So I've got the counter as 2 and 1. Okay, for AB, right? So let me again put a very big one, whatever the question that we had here. I'll copy this and paste it, run it over here. So if you see here, the counter value is always ending at 1. That is because the last character of a string will be null. Okay, the last character of a string will be null. In C program, string is ending with a null character. So that is the reason why this is happening. So all I'm going to do is -1, because since we are adding +1 here, it is good to have -1 in the length. Now if you code, now the counter 2 is the last one. Can you see this, guys? This is BC. So that is the last one counter. Okay. Now, what they are asking is, what is the maximum of it? Okay. What is the maximum of it? Now, if I have to take the maximum of it, I'm going to initialize one more variable. Let's call it as maximum equals 1. Now, before changing the counter, all I have to check is if the counter is greater than the max, change the max to counter, and then change the counter. Okay, before that, do not change the counter, store it in the max. Okay, so if the point in storing it in the max is because when we are coming out of the loop, we can just print the maximum. Yes, Akash, you are right. So we are just need to store it in the max. So once we run the code, we will get max as 5, and that is what is expected out of us, right? A, B, C, D, E. So there are 5 characters. So and that is what is expected out of us, right? Now, if you remove 2 letters from here, then we need to get max as 4, and that's what we have got. Okay, so even this question was very simple, guys. What they have done is a little logic that they have added here. That's the only thing. So what we have to do is you just have to store the counter in the max. So all you need to understand is, why do we write this? Why are we writing this way? So this is to store the maximum. This is to store the maximum of counter in a variable called as max. That's it. As simple as that. Even this code will be available as a zip folder, guys. You can take it and then check it out after the end of the session. Okay. Okay, so let's move on to the next one. So the next question that they have asked is to find out the second maximum element in the array. Okay, we need to find out second maximum element in the array, given array, without using sorting. Okay, without sorting the entire array, we need to find out the second maximum element in the array. So I'll tell you guys, they will not tell without sorting do that, but what they are going to tell is, so they will be giving a lot of test cases, 30 to 40 test cases will be appearing in the question. So in that, we just need to pass maximum number of test cases in order to get maximum mark. Okay, that is the whole point. So now if you are getting maximum number of test cases passed, then there are more likely chances that you will get very good mark in coding section. Now if you have to do that, the whole point is, how do we minimize the complexity of the algorithm, right? How do we run the code faster than anybody else? Now if you are able to do that, then you will be able to clear most of the test cases. Okay, so I'm going to take one array here. So in this array, what we need to find is, we need to find the second max element. Okay, so we will be knowing that the second max element in this is 7. The maximum element is 8. The second max element is 7. Now I'm going to calculate the length of the array. So this is an integer array. So you guys know how do we calculate the length of the array, right? So we calculate length of the array by using size of operator, size of ARR divided by size of int. This is going to give you the length of the array, and I'm just going to loop an array, loop through the array by using a simple for loop and do a printf of a of I. Okay, I'm just checking if things are going well in my code. Okay, not given this. Yeah, perfectly fine. So now the thing is, we need to find out what is the, first we will find out what is the maximum. So for that, I'm going to use a variable called as max, and I'm going to assume this is the first element of the array is the maximum. This is just an assumption, and I will be clearing the assumption in the later part of the code. Okay, so what I'm going to do is, if the current element is greater than max, and all you have to do is change the max. Right, simple guys. If the current element is greater than the max, you just store max is equal to ARR of I. So after the end of the loop, all you need to do is just print the maximum value. Okay, so this will give us the maximum element in the array. There is no doubt about it. It is simple, right? Sorry, this is ARR of 0. So this is a very simple code. This is going to give us the maximum element in the given array. As you can see, the output is 8. Correct? Now, the question that they have asked is not the maximum element, but the second max element. Now, in order to find out the second maximum element, there are multiple approaches, but I'm going to give you a very short and simple approach. So every time when the current element is greater than the maximum, I am replacing the maximum, right? So here what I'm going to do is, in order to find the second maximum element, before replacing max, store the previous max in some variable, and that will be your second max. Right, guys? Before changing the max, if I am storing, so let's say for example, for the first time 1 is the max, and when I am seeing 5, then I will store 5 in the max, but I will store 1 in some random variable. So that 1 is my previous max. Previous max is nothing but the second max, right? Now the moment I see 7, now 7 will be stored in max, but 5 will be stored in previous max. Previous max again is nothing but the second max. Now when I'm seeing 8, now I'll store 8 in max, and I'll also store the max, current max, which is 7. That has to be stored in some variable called as previous max. Okay, so I'm going to have a variable called as previous max, and I'm also going to assume that to be a of 0. And here is where I'm going to do that magic. Previous max will be having max. Before replacing the max, I have included one more line. Previous max is equal to max. Now, yes, what I can do is I can display previous max along with max. Copy this code and I will execute it. As you can see, the maximum is 8 and then the previous max is 7. So previous max is nothing but the second max. So, but there is one problem here. Let's try putting this 8 here and then 5 here. Again, our answer, the expected answer is 7, because 7 is our second max. Again, our answer is 7. But let's try running the code and checking whether it is giving 7 or not. So the answer given by our code is 1, which is wrong. Can you guys tell me where should I fix the code? Okay, these kind of questions TCS Ninja might ask. Where should I fix the code? What I should add in the code so that I will get the second max properly? What should I add? Any idea, guys? Yes guys, are you able to hear now? Now this is also false, right guys? So the whole idea is, if again I am doing else if, the whole idea is again I have to compare it with my previous max. So there is a chance that my current element might be within the max and previous max. There is a chance. Now where will I go and code for that? So that is where I have included else if as well. So once I'm including the else if, I'm again comparing the previous max with the current element. Now previous max is with current element is again false. You don't have to change anything. Now for the second time, since it is true, it will not even evaluate this statement. That's how else if works, guys, right? So that's how else if works. So I'm not even evaluating the second statement. Now the third statement, since it is false, I would have to evaluate. So by that time, max would have become 8. Previous max will be 1. Now again, I might have to evaluate 7 greater than 1. So 7 greater than 1 is true. That means what? I just have to change my, so this is the second condition, right? This is the else if condition. So if the second else if condition is true, all I have to do is just change the previous max to the current element. So now once that is done, I'm going to do the same thing for other conditions as well and for this condition as well. But here the thing is, now the second max is 7 and the current element is 5. The current element is 3 here. So this is also false and this is also false. So overall idea is simple, guys. Uh, if I have an element which is in between the previous max and max, we just have to change the previous max. So that's the whole idea of it. Okay. And let's understand one more thing which is very clear. So let's assume that I have one variable here which is 8. Let's say this is 2. Let's say this is 7. Okay. Now let's try running the code, guys. Now if you see, max is also 8 and previous max is also 8. Again, it is not a very valid scenario. Now what do you think we need to write in order to address this case? Just try this, guys, out. So if for the given array the second max is not again coming properly, what should I do for this? Again, guys, the whole idea is, if my previous max and second max is number, I mean the element number 1, and if the first element itself is max, right? That's the whole point, right? The first element in itself is max. In that case, I will never be able to identify the second max because this condition will never be true. So for this reason, what I'm going to do is, if both are same, if previous max and max, if both are same, then I'm going to say if previous max is equal to max, then you just change it. Now if I do that, let's try running the code. Now we got 8 and 7. So this, you can take a screenshot of this, guys. Anyway, this will be available after the end of the video. You can also take a screenshot of this one. So this is a O of n time. This is a O of n time code for predicting the second maximum element, for printing the second maximum element in the array. Okay, and all we have done is only we have just used one single for loop. We have not sorted the entire element, right? We have not sorted the element. We have not changed the array. Okay, we cannot change the given input. We cannot change the array. Okay, I have not changed the array and I have not sorted the array. So I have not done anything, but I'm able to again find out what is the maximum, and I am also able to find out what is the second maximum element in the given array. So you can take a screenshot of it and then you can change the input and then just try it out. Okay, So the last condition that I have added is just to make sure if they both are same, please do not make both same. That's it, as simple as that. Since they both are starting from the same point, there might be a chance that they both are same, and that might be the max, and that is why I'm including the last condition as well here. Okay, so once this is done, we will be able to get the maximum and second maximum element from the given array in one single loop. Okay, by writing one single loop, we will be able to get it right. Okay, so thanks a lot guys for watching. So I think I've completed my questions for today. Okay, so we will again meet in the next technical webinar very soon. So I have taken the request, guys. I have taken the request, Akash. So we will try to put as many as technical videos as possible. So I'm glad that you guys are liking it. So definitely we will be working towards giving you more and more questions, not just for TCS, maybe for Infosys, Wipro, and many other companies as well. Okay. So we will increase the number of technical videos whenever it is possible for us. Thanks a lot for supporting us. And make sure that you subscribe to our channel and then like the video. And then this is our platform from which you can take the quizzes and then check your in this quiz, guys, all of these quizzes are having explanatory answers. So make sure that you are attending all the questions, and all the questions will have a correct answer. It will be MCQ based question. So please answer all of the questions appearing in the quiz. Almost all the quizzes are free here. You don't have to pay anything. It is a free version of all the quizzes. You can try checking it out. So aptimitra.com is the website. So we have uploaded tons and tons of quizzes here, and also we have videos to watch. Okay, you have videos to watch and then learn. You can learn from it, and you can, as you can see, it is not just TCS. We have also uploaded Capgemini question papers. Okay, so all these quizzes are listed over here in this website. So please go and check it out, and everything is free for you to take. Okay, so have a good learning, guys. See you in the next webinar. So we will try increasing the number of webinars as much as possible. Thanks a lot for supporting us, guys. Subscribe and then like us. Bye bye.